All right, let's check out number 12. It says if the integral from -1 to 3 of 2 times g of x plus 4 dx is 22, and the integral from 10 to -1, well, that seems backwards, so be aware of that, of g of x dx is 12, then the integral from 3 to 10 of gx dx is what? All right, so we can see that this one is probably more helpful to go from -1 to 10 of g of x dx, which is going to equal -12, because if we switch the limits, it makes it the opposite, so -12. And so notice here, we want to find from 3, the integral from 3 to 10. Well, we have -1 to 10 here, and from -1 to 3 here. Although this has some extra information in there. It's not just of g of x. So we're going to have to use this to help us. But really what this is going to be the integral, and you can write this different ways, but this is going to be integral from 3 to 10 of g of x dx is going to equal the whole thing from -1 to 10 of g of x dx, and we want to subtract out from -1 to 3 of g of x dx. So we already know that this is -12. That's right here. And so we need to find this thing over here, which is related to our first part. So let's separate this out some by our rules of integrals. So we have, we can think of this as -1 to 3 of 2 times g of x dx plus the integral from -1 to 3 of 4 dx, and we know that's equal to 22. This first one here, we know we can bring out that constant. So this is going to be 2, integral from -1 to 3 of g of x dx. Now this one, this is a horizontal line at 4 for an interval of 4. So this is equal to 16. And that is a rule when you have an integral from something, so like from a to b of a constant, it's this distance, -1 to 3, times the constant. And we could actually integrate and figure that out as well, but that's equal to 16. And then, so this part equals 16 equals 22. We can subtract 16 from both sides. I'm running out of space here, but subtract 16 from both sides would give me 6 is equal to 2 to integral -1 to 3 of g of x dx. Divide by 2, we know that this is equal to 3. So dividing by 2, you'll get 3 here. So we have -12 minus 3 is going to be our value. So it is going to equal -15, which is right here. All right, next one, 13. The graph of f on the interval -4 to 7 consists of 3 line segments and 2 semicircles. As shown in the figure above, what is the value of the integral from -4 to 7 of f of x dx? Well, this is just, we've got to remember this is going to be related to the area. We just have to remember that areas above the x-axis are positive and areas below the x-axis are negative. And so we're going to use geometry here. I notice we have this rectangle right here. That's 6. 1, 2, 3, 4, 5, 6. So that's a positive 6. This little guy right here, that's a triangle. Base times height divided by 2. That's a half. Here we have a semicircle. So a semicircle is pi r squared divided by 2. We do divided by 2 because it's a semicircle, not the whole circle. Well, the radius is 2. So that area is 4 pi divided by 2, which is 2 pi. So 2 pi. So right now, our positive parts, so the area, well, we don't even have to put it here. It's going to be here. The integral, the definite integral, is going to be 2 pi plus 6.5, which I'm going to put 13.5 because I'm noticing in my answers it's using improper fractions. And now let's come to this other section. This is a semicircle. This is going to be negative. So this is pi times the radius squared. The radius is just 1 divided by 2. So this is 1/2 pi, but it's negative because it's below the x-axis. And then this little triangle right here, base times height divided by 2. Base is 2, height is 1. So 2 times 1 divided by 2 is 1. So this is -1. This was negative pi over 2. So -1 minus pi over 2. As we simplify that, 2 pi minus ½ pi is 1.5 pi. So 1.5 pi. 13/2 minus 1 is 11/2, because this is like 2 over 2. So we got, again, fractions. So 3 pi over 2, or 3/2 pi plus 11/2 is the integral, and that is B.